To Tesla AI Day number 2 that took place last Friday on September 30th. I want to talk about three things today in this episode. I think number one, I want to focus on the humanoid robot and why I think is a fantastic idea to pursue that. I think number two, I want to talk about the excitement I have that Tesla is innovating across the compute stack, and to me that's a particularly important subject because I started a while ago defining companies or endeavors in general by what are you doing across the compute stack. Everything, the way we at Orange Capital Partners, the way we define wealth creation is literally innovating around the compute stack, because compute is it's the path towards wealth creation. It might not be the only one, but at least for now, where we stand today as a society, as an economic entity or world economy or whatever you want to call it, we just compute is where it's at. And number three, I think I want to talk a little bit about the talent and the attraction of Tesla as a company and the flywheel. Flywheel of talent and flywheel, that's related to the first point of the humanoid robot. It's the idea that you start something that kind of feeds on itself, some sort of regenerative growth. It's not exactly what the regenerative growth means, but it's related to it. So those are the three things. It's Not Even Wrong podcast. It's October 5th, 2022. This is Krim Delko. For the day, the fund is down 2.2%, market's down 20 basis points. For the year, we're down 40.5%, the market's down 20.4%, we're underperforming by 20.1%. The bulk of the underperformance goes back to, unfortunately, Elon Musk buying Twitter and that whole thing going on there. And I don't really want to talk too much about it. I spoke yesterday about it. I think there's positive spin to it related to cryptocurrency and particularly Bitcoin and the peer-to-peer payment system. So those are good things, and I think Musk has a phenomenal track record in making something out of nothing, and maybe even this is another example of where he can surprise us. He does have one failed acquisition, which is SolarCity. I think SolarCity was not a good acquisition, and maybe Twitter is the same thing. Hopefully not, but I don't want to focus on this here. I think let's talk about AI Day. Much more positive, much more interesting, much more exciting, much more inspiring. Let's start with the humanoid robot. So a lot of people ask me or ask themselves or ask people in the public, why are they doing this? Why are they doing this? And I think it's a legitimate question, because you are draining your resources, you are distracting yourself, and most importantly, you're spending money. Why are you spending money here? Why not spend money on, let's say, full self-drive? Well, there's two reasons why. One is there's a lot of transfer learning. There's a lot of learning you can actually literally transfer, so that's a good thing. And I think secondly, you can actually learn from the robot and build this flywheel. What is it you're learning? Well, for one, you learn dexterity. So you're learning how to deal with a system that needs to be incredibly precise, that needs to be very sensitive towards, let's say, touching things, holding things, those sort of things. So that is definitely transferable to the car. But I think the other transfer, so the transfer from the car to the robot, is a lot more interesting to me. What's going on here? Well, you have, and they emphasize that many times, you have this, sorry, I'm here next to a field of players. So you have a self-driving car, which is a robot on wheels, and then you have a robot on legs, and that's really it. Now, the problems that Tesla is attacking are things like carrying stuff around. They showed pictures of a robot filling battery stacks. So where is this going? It's going towards delivering tasks, certain tasks that humans can do that this robot could be doing. Of course, it's just the beginning. Hopefully, in the near future, we have humanoid robots doing things that are really useful. Useful as defined as solving a problem that we humans have. That's what useful means. So it's solving a problem that we have. Carrying stuff in a factory, maybe making sure that stuff doesn't fall down, maybe even some sort of security function, those sort of things. And the beauty about this is we don't know where this might be going. This might be going towards things that we can't imagine. I mean, just one example: a self-driving car drives itself on a highway, right? And people, let's say I choose to stay in a traffic jam and go bumper to bumper versus going, let's say, around the highway and driving just because it's more convenient. So this is just one example of a use case that you wouldn't think that is actually a use case, but it is a use case. And the humanoid robot could have a lot more use cases along those lines. So what's important here, though, is it's the learning, it's the flywheel, it's the transfer learning, it's the ability to innovate, it's all of those things. And that leads me to the second point, which is the innovation across the stack. And I think for me, this is very, very dear to my heart. I've spoken about this in the past. I am taking Onur Mutlu's course about computer architecture for the second time. I think he's just very good. Plus, all his courses are online. So it's a good example of free access to knowledge that, in my view, is indispensable for wealth creation in this day and age. Because Onur Mutlu is going through the stack, explaining in a lot of details how you can, first explaining what the stack is, but then more importantly also explaining where, let's say, current problems and workloads could be tackled more efficiently within the stack. So let's say you could be working on different types of computer architectures, for example, data flow versus von Neumann architecture. You could be working more on the memory side of things because that's the bottleneck. So things like that. And Tesla is almost an applied course of Onur Mutlu. Almost everything in the stack, almost everything starting from the physics. So for those who you don't know what the stack is, just Google it, computer stack. There's, I think, 8 layers. It starts with physics, then the transistor, then the gates, microarchitecture, program, algorithm, and then the problem. So think of it this way. What is computing? What is the compute industry? The compute industry really, builds machines that allow us to formulate a problem in a way that it gets executed or solved with electrons all the way down in the stack, all the way down in the transistor level. And that's kind of what computers are. And we all associate computers with PCs and laptops and things like that. Of course, computers are a lot more than that. And that's one of the things that has happened in the last couple of years because of the machine learning revolution. There has been a lot more, people have been thinking about how to make different types of computers that could potentially solve different types of workloads and all that kind of stuff. So what I'm trying to say here is that in the past, we used to just go to Intel and maybe AMD and maybe NVIDIA and buy computers. Today, because the problems are different, because the problem sets are different, also the execution all the way down to the stack is different. And Tesla is attacking almost every level of the stack. And the AI Day was a beautiful example of that, where almost each presentation could have been, it could have been titled, okay, stack number 1, stack number 2. They're going all the way down to the physics level, where they're solving, let's say, the cooling problem of a particular chip. I think it was when they spoke about Dojo, they talk about cooling, they talk about interconnect, they talk about all these things. Then they talk about the software which connects, let's say, the learning so the algorithms that need to somehow be translated onto the Dojo tiles, which then do the learning. and there's certain software which makes that more efficient. So they are innovating across the stack. And what I've heard many times in the presentation was the sentence, we went to vendors, we worked with vendors, we realized we have to do it ourselves. And this is the key. Have to do it ourselves, which means we're creating our own compute infrastructure to solve our own problems with the goal in mind to solve for real intelligence, for real life intelligence, which then as an emergent property could also lead to artificial general intelligence. Now, this is not even important. Musk said it in the presentation, we're not optimizing for AGI, but he thinks that it's just an emergent property, which is actually an interesting observation. So this point, again, I can't be emphasized more enough. If you agree with me that compute is going to create wealth by solving big problems, well, there's no company, no other company in the world innovating across the stack and also having the problem itself. So the problem, which is important. So the actual problem. So this is not some general compute company like NVIDIA and Intel or AMD. Nothing wrong with them, but they still have to. They don't have the problems in their face. Tesla has. So Tesla is an NVIDIA on top of a car company, or a car company on top of an NVIDIA, and this is what's so great and unique. I can't emphasize enough, the uniqueness of Tesla is just the positioning, the way they position themselves between the physics layer of the stack and all the way up to the problem. It's one company, one integrated company. And this goes back to our concept of the natural Sharpe ratio, which at the core is requesting a rapid iteration, which again is something that was visible and hearable across the presentation. Iterate, iterate, iterate. Fail fast, fail with a low level of errors, or you can make errors, but don't make them too expensive, and then the cost of error correction should be low too. This is what Tesla is optimizing for: fast iteration, low errors, and low rates of error correction. You combine all of this, you're going to get to a company that has the potential to solve massive problems and create a lot of wealth. The last point I want to get through, which is, again, they're all the same importance. I just had to be chronological. I can't talk about the three things at the same time. So they're all very important. Therefore, also this third point, very, very important, which is the talent acquisition. So how do you get talent to join you and work on this within the culture that you've created, which is rapid innovation? We take that for granted because Tesla has delivered on this. I mean, look at these boys and girls. I mean, I call them boys and girls because they're all very young, but no disrespect. They're obviously adults, educated, functioning adults. Nevertheless, they have, and I mean this in a very good way, they have this childish curiosity and this excitement, which is one thing. Go to an I/O event of Google or Apple or something, Apple developer event, or even worse, something like Intel. I mean, what you're going to see? You're going to see, quite frankly, bored adults talking about things that they don't want to talk about. Most of the time, not all the time. Particularly Google is a tricky one because there's enormously useful work that is done there, but it's a little bit of a honey trap, to paraphrase Musk, because a lot of engineering, a lot of good things that could be happening aren't happening, and that's on Google and on the leadership. Nevertheless, again, I want to talk about the talent because the flywheel of the talent is sometimes a little bit underestimated. In other words, being able to attract talent that has a certain culture and then nurture that culture and then attract more talent that has that culture and keep nurturing that culture, that is a competitive advantage in itself. And that's something that I think Tesla is very unique at because of Elon Musk, and that's the one-man risk of Elon Musk. That's the way I would paraphrase the sort of the talent question. But I think not to underestimate the importance of Musk and his ability to galvanize all this engineering talent. I think that's key, and I think this event has brought that home. So to summarize, my big three takeaways from this AI Day: number one, we have we innovate across the stack, which is huge, and which is the key to wealth creation. Number two, we have a flywheel effect within the humanoid robot. The humanoid robot is in many ways very, very useful and incredibly good for Tesla. And I don't care if it's being priced or not priced in the market and all of that. It's all fine. In the long run, the market's a weighing machine, and we'll see where that all leads us. But it's a good thing. It's a very positive thing. It helps transfer know-how from the full self-drive suite to the humanoid robot and back and forth. It helps with dexterity, which I think is a huge thing for the car. So precision, softness. I mean, you know, let's say actuators, and how do you translate a video stream to the gas pedal, and how do you make that user experience better? All those things can be learned from the humanoid robot and transferred back to the car, and vice versa. So these are all very, very useful flywheel type of things. And three, the flywheel of talent acquisition and talent retention and culture creation. I think the most underappreciated part of Tesla, in my view, and very, very important. Thank you.